Hello Explorer, welcome along to a bonus bite of searching through the solar system. It's time for a brand new Fun Kids Science Midweekly. My name is Dan, and this week it's a questions special. I love discovering just some of the most amazing parts of the universe with you and seeing what you're wondering. Any questions about science, send them over to me. You can do that as a message on the Fun Kids website. My favourite, though, is when you send over a voice note on the free Fun Kids app and at funkidslive.com. That way I know what you're thinking, I know who you are, we'll get you on, you can star on the show. So fire over that voice note, really easy. You can click the big red record button on the website and on the app. Let's get on one of those. Here's a question from Zimbobi.
Hi, my name is Zimbobi. Why is Pluto not a planet anymore?
Hey Zimbobi, why is Pluto not a planet anymore? Well, Pluto was a planet. It was the 9th planet in the solar system. You had Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto. It was about 3.7 million miles from the sun. Although its orbit is very elliptical, shaped like an oval, so it gets much further away and then much closer than that. It was discovered in 1930. Almost 100 years ago, and for most of that time, it was a planet until 2006, when the International Astronomical Union changed their minds. They redefined what counts as a planet. For a planet to be a planet, it needs 3 things. That's what they say now. Number 1, it needs to orbit the sun. Well, Pluto does that, check. Number 2, it needs to be spherical. Pluto is. It has enough gravity to pull itself into a round shape. Third, and finally, this is where it got a bit sticky, a planet must clear its orbit. Pluto doesn't do that. It's quite tricky to explain and define what clearing an orbit is. Basically, it needs to be the boss of its area. Anything smaller really needs to be sucked into it and absorbed or flung away, or it needs to orbit it like our moon does to Earth. And Pluto doesn't do that. It shares its space with many other similar-sized rocky objects that go round the sun. It's like it's got neighbours on the same street. And because of that, because it's not the boss, it's no longer a proper planet. And that's been the case for, almost 20 years now. Since 2006, Pluto has no longer officially been a planet. It's a dwarf planet. And there are other ones even bigger than Pluto nearby. So it's kind of amazing that it ever was, really, Zimbobi. Thank you for that voice note. Let's get on another question. Here's something from Zara, who wants to know, if you get really deep down into the ocean, does the temperature of the water get warmer because you're closer to the Earth's core? Well, you would think it was that way, wouldn't you, Zara? But it's not, really. There's a few reasons why. You see, the water in the ocean is still quite far away from the core, still miles and miles outside of the centre of the Earth. So it's not getting heat from that. Ocean water is mainly heated by sunlight as well. That only heats up the very top of the sea. Water at the bottom doesn't get that sunlight. Also, the water at the bottom of the ocean has been there for ages. And there isn't a lot of tide. There isn't a lot of currents down there. So there's nothing that's blowing or moving warm stuff nearby. And remember, warm things rise because they are less dense. They tend to be lighter than the cold stuff, which is heavy. So the cold water sinks to the bottom. The warm water goes up, which means the deeper in the ocean you get, the colder it is. Zara, thank you for that. Here's one from Dylan. Dylan, 7 years old, thank you for this. Why do car wheels look like they are spinning backwards when they're going fast on the road? Have you ever seen this when you're on a car journey? You look out your window, maybe you're on the motorway or the highway, whatever it is. The wheels of cars that are going fast, they kind of look like they're spinning backwards. It's a really amazing trick of your eyes. It's called the wagon wheel effect. It's a little bit mind-blowing, really. Think of what you see and how you see anything. What you're doing is seeing hundreds of pictures, still frames, that your brain is putting together and making seem smooth. Now, your eyes can see 200 of those still images a second. What your brain works out, though, it kind of changes. If it's anything more than 16 pictures a second, your mind will blend those into a smooth motion. 24 pictures a second, that looks natural. That's why movies are normally in 24 frames a second. Sometimes you get films that are in 60 images a second. You can slightly pick up things being a bit clearer around the edges, but nothing too much. Anyway, what happens is your brain is making these things seem smooth, but it gets too quick. Your brain can't really figure it out. So your eyes will get a picture of the wheel in one place, and then again in another, and another, and another. And by the time your mind has made sense of it, it's going backwards. So it's the wagon wheel effect, Dylan. It's all to do with the difference in how your eyes and your brain understand something when you're going at high speed. Now, we'll get a question on in just a second, all about why your brain starts to hurt when you're eating cold things. I just want to tell you, though, you have 2 more chances left to see Fun Kids Science Weekly live. We've been doing this brilliant stage show all summer, a live science extravaganza. We are exploring the universe with deadly beasts, with genius guests, with mind-blowing experiments, and we have something from outer space. All right, and we've got just 2 more shows this year. We're playing at Leeds on the 18th of October, then in Chelmsford in the UK a couple of days later on the 21st of October. And then we'll be done for 2025. So you've got just 2 more chances to come along and see our live show. If you want to find out more, grab a grown-up. You can get your ticket, funkidslive.com/tour. All right then, let's get back to your questions. This is a brilliant voice note from Alfie.
Hi Dan, I'm Alfie and I'm 9 years old from Reading. I want to know, when I eat too much ice cream, why do I get brain freeze? Bye.
Brain freeze, Alfie. Its very smart official science name is sphenopalatine ganglioneuralgia. Neuralgia. It's something that my dad knew. Like, the only really smart science word he knew was neuralgia. So if I ever got it on holiday, he'd say, "What was that, brain freeze?" Brain freeze. You mean neuralgia. It's because your brain and your mouth get a bit confused, Alfie, when you put something cold in there. So when the ice cream touches the roof of your mouth, it's very close to blood vessels, those the little tubes that carry blood all around your body. The ice cream pretty much touches those, and they get very cold very quickly. Your body doesn't like that chill, so it makes them wider to get more blood in there to bring the warmth back. When they get bigger, they accidentally trigger the pain-sensing nerves that are nearby. They get a little bit confused, and they let your brain know that something strange is hurting. The problem is, your brain then gets confused because it interprets that pain coming from your forehead, not from your mouth. So that's why when you put something cold into your mouth, your forehead and head start to hurt. That's why you get brain freeze, because it's just getting a little bit confused. There are things that you can do to really help it out, though. You can press your tongue up to the roof of your mouth on the palate. That warms it up. You can drink warm water. You can breathe through your mouth with your hand just slightly over it, because that will raise the temperature in there, and it should help warm your mouth up quicker, which will let your brain understand what's going on, Alfie. Thank you very much. Let's get on one more question, shall we? Charlie, why do whales sometimes explode after they've died? It sounds ridiculous, but this can happen. You might have seen clips of it. It's strange, it's gruesome. Huge whales that sadly die, they get washed up on the beach every now and then, and they'll sometimes explode with their insides being thrown everywhere. It's because when a whale's died and its organs are decomposing, they're breaking down. That's what happens when a creature stops living. The whales are so big, it makes gas. A lot of gas. But the problem is the whale's skin, its blubber, is thick and strong. So the gas has got nowhere to leak out and escape. So all that gas is being made, it can't get free, so it builds up and it builds up. The pressure gets higher and higher and higher until finally it can't be held in. It bursts and it explodes, Charlie. That's what's happening. thank you very much for your question. If you have anything that you'd like answered on the podcast by me or another genius, one of my mates that I'll get on for you, send it as a voice note to the Free Fun Kids app and at funkidslive.com. Before we go this week, let's check in with Amy Aviation again, shall we? We've had her for the last month or so while we've been exploring aviation with our very special Reach for the Sky episodes, and I thought we'd check in with her again today. You see, Amy loves planes and aviation. So we're finding out all about the different ones that fly through the air and how they can be really light, but also really tough. Amy's looking into composites this week.
This is a podcast from the children's radio station Fun Kids. Listen on DAB digital radio in London or online at funkidslive.com.
Amy's Aviation, with support from the Royal Aeronautical Society.
I'm waiting for the bus and I hope it's a double-decker because I love to sit at the top. Did you know there's a plane that's also a double-decker? It's called the A380 and it's a super jumbo. The largest passenger plane ever built, so it has plenty of room at the top. Want to find out some more? The company that made the A380 have something else in common with buses too. Their name. They're called Airbus. Originally, all they set out to do was build a massive plane that could take more than 500 people. After trying out loads of designs on paper, it seemed that having 2 floors was the simplest way to do this. It wasn't easy though. They had to tackle some big problems. The first one was the weight. Now, as we've been finding out, planes have to keep their weight down. Not because they're on a diet, but because the heavier they are, the more fuel they need to get them off the ground and reach their cruising speeds. And that's not good for the environment or our ticket prices. A normal plane weighs about 300 or 400 tons. That's as heavy as 40 elephants. The A380 is twice as heavy as this though, even before anyone has got on board. It weighs as much as 80 elephants. I wonder how they would all do up their seatbelts ready for takeoff.
Please would all elephants ensure all trunks are placed in the overhead lockers and prepare for takeoff.
Okay, there aren't real elephants in an A380, but all that weight could make it just too difficult to get off the ground and stay up in the air. Luckily, the designers had a few tricks up their sleeves. Loads of tests were done to make sure the shape of the plane was as aerodynamic as possible so it could cut through the air easily. If you've ever walked with your umbrella on a windy day, you'll have seen for yourself how much the wind can slow things down. Do you know how they test out different shapes? Here's a clue. It's a wind tunnel. A model of the plane is secured in a tunnel and enormous fans push air past it. Sometimes smoke is used to make it easier to see. Sensors on the plane show which surfaces are being pushed by the air the most, so the designers can alter the design to make the air pass as smoothly as possible over the plane. Wind tunnels are pretty expensive, so designers also use lots of computers to run tests. And it's important that they test the shape thoroughly, because once you've built a 400-ton aircraft, well, you can't really take it back to the shop. There's another way that the designers made the A380 as efficient as it could be. It was all to do with the materials it was made from. Normally, aircraft are mostly made of aluminium and steel. As metal are heavy, the designers at Airbus wanted to use as little of them as possible. So, a quarter of this massive plane is made of something called a composite. Do you know what that is? A composite is just mixed up materials. Think of it like this. Have you ever been to a birthday party with a piñata? You might have seen that the piñata was made of a composite of paper and glue, squished up into a shape and left to go hard. Before you give it a good bashing with a stick, mixing 2 or more things together into composites can give you a material that's stronger than the separate parts would be on their own. Engineers have used composites in aircraft for decades. Even the very first planes 100 years ago had fabric soaked in resin to make thin and strong skins for the fuselages. The composite that makes the A380 so light is a bit more high-tech than that. scientists go right down into molecules of carbon to make... Can you guess? It's called carbon fibre. Carbon atoms are stretched into long ribbons that are packed together in a plastic and heated up to really high temperatures to mould them together. They're 1/4 as dense as metals like steel, but 2 or 3 times stronger. The A380 is 1/4 carbon fibre, but there's also a plane that's half carbon fibre. It's called the Dreamliner. As well as being light, it's easy to make into different shapes too, which all help the A380 become a very successful super jumbo. This is my ride. I'll have to settle for the top deck of the bus for now. Chocks away.
Amy's Aviation, with support from the Royal Aeronautical Society. Find out more about aviation at funkidslive.com/aviation.
So that was a podcast from the children's radio station Fun Kids. Listen on DAB digital radio in London or online at funkidslive.com.
And that is it for this week's Fun Kids Science Midweekly. We'll be back in just a few days' time with another very special episode filled with geniuses and your questions. If there is something you want answered, make sure you leave it as a voice note for me on the free Fun Kids app and at funkidslive.com. And I will see you in a few days. Thanks for listening.